Hello everybody, and today I have made a touchless piano because of COVID-19. I was excited to start this project, so I got some materials and went to work. The main component of this contraption is an ultrasonic sensor. An ultrasonic sensor sends out echoes that are kind of like echolocation and returns a value of how far away an object is away from it. I used this in order to track how far my piano was from the sensor in order to play notes. I wrote some code, and before I knew it, I had a somewhat functional touchless piano. As you can see, it's not the best, but it gets the job done and I'm quite proud of it. Well, now that it's working, let's play a song. I'm aware it may be hard to hear the notes, but try your best to hear them. You'll also see that most notes take some time to get recognized and then play. Precision is key here, and again, the keyboard is never 100% accurate. So in this section of the video, I will be dissecting the Python code. I will not be going into Arduino code just yet. So, here we have our basic imports. We import serial, which I'll be getting into a little bit later, and then we import wind sound, and I define that to be called piano. And basically, what wind sound does is it allows us to play sounds on our computer. So, serial port, we make a variable named serial port, will be equal to serial.serial, and then we enter in this information right here. This COM4 connects to the Arduino, which is a microcontroller that I'm using to connect to the ultrasonic sensor. And here is our serial number. So, from there, now that we're connected to the Arduino, and the Arduino is connected to the ultrasonic sensor, we now have access to the data of the ultrasonic sensor. So, then we read the serial port to get the value that the ultrasonic sensor is telling us of how far away an object is. And then it gets parsed, that data gets parsed through here, so it gives us the bare bone value, so that it can be comparable as an integer. And then that integer is compared to 4 or 3, 6 or 7, 9 or 8, 11, 12, 13, 14, or 15, 16, or 18, 17, 21, or 22, and based on whether the final distance integer meets that requirement, it will play a specific sound. For example, if the integer called final distance equals to 4 or 3, it will play a C note on the keyboard. And that's essentially it for all of this, which was, to my surprise, a lot simpler than I thought it was going to be when I initially started this project. The hardest part, in my opinion, was this: getting the correct, the correct parsing. So in this section of the video, I will be explaining the Arduino code. So, here we get our input pins on the microcontroller. And if you didn't know, Arduino is a microcontroller, as I said before in the Python section. So, we create these two variables right here. And these will be used to calculate and hold the data of how far away an object is from the ultrasonic sensor. And down here, as I showed in the Python section, the reason I use 9600 in the Python section is because Arduino, or the microcontroller, is also using the same serial number of 9600. So that's how the Arduino and the Python pair. And over here, I'm essentially just giving energy to the ultrasonic sensor so that it can continuously give me data on whether or not something is in front of it. And then based on that data that the ultrasonic sensor gives me, it goes through this equation, so duration divided by 29 divided by 2, and then that just gives me a semi-accurate number of whether or not, or rather I should say how far away an object is away from the ultrasonic sensor, and that will be used to calculate the distance. And then I print it to the serial port, which then, like I showed before, Python will pick up. Here is a photo of the finished product. Thank you all for watching. If you enjoyed what you saw, consider subscribing and giving this video a like. Have a good day, everybody.